Hi, I'm going to do the Maclaurin's theorem, or the Maclaurin series question from the 2018 January paper, question 3b. It's worth 8 marks. This is the question. Show that the first 4 non-zero terms in the Maclaurin series expansion for f of x, which is equal to the square root of 1 plus x, is given by. The square root of 1 plus x equals 1 plus x over 2 minus x squared over 8 plus x cubed over 16. Part 2. Hence approximate the square root of 1.4 using the first 4 terms in the series. Now this, for part 1, this is the answer that we're going to try to get here. Okay, and then we'll use it for part 2. Also note that at the back of the exam paper, you're given the theorem for Maclaurin's series, and it's labeled Maclaurin series, so it's not too hard to find. And there's 8 marks for this. So the first thing worth noting is that f of x, which is the square root of 1 plus x, can be written like this. F of x, the square root can be written as to the power of a half, as 1 plus x to the power of a half. Okay, that's one thing worth noting. Now, there's a few other things worth noting. The formula for Maclaurin series. It's f of 0 plus x f dashed 0. This here means differentiate. This dashed here means that you're going to have to differentiate f of x once. Plus x squared over 2 factorial times f double dash 0, which means it's the second derivative. 1, 2, right, for the second derivative. Plus x cubed over 3 factorial times f of 3 of 0, which means the third derivative. Now, this is 1, 2, 3, 4 terms. They're separated by plus signs. So that's 4 terms already. We just have to try to follow this if we understand what this formula means. The first thing we need to do is differentiate. Now, we're not going to differentiate f of 0. We will differentiate f of x. And I'm going to use that x is 1 plus x to the power of a half. That f of x is this square root, but I'm writing it like this because. So how I do this is I'll write down f of x is equal to 1 plus x to the power of a half. Now, to remind you, the general rule for differentiation is if y is equal to x to the power of n, then dy dx, or the first derivative, dy dx, or we can write it like this, y dashed x if you want, is equal to nx to the n minus 1, which means you bring down the power and you subtract 1 from the power. So if we look at our f of x now, if we want f dashed x, the first derivative, we will bring down the power and we will have a half on 1 plus x to the power of a half minus 1. Now, this actually, to be totally correct, this is a chain rule question. So we would have to differentiate what's inside the brackets as well, which means if we differentiate it 1, it's 0, and if we differentiate x, we get 1. So we're multiplying it by 1. So that makes no difference to this because it's just 1. Multiplying by 1 leaves the thing the same. So what we're left with is a half on 1 plus x to the power of minus a half. That's the first derivative. Remember, these don't have zeros in them, they have x's in them. Then we do the second derivative, f dashed x, which means we're going to have to differentiate this thing that we've already done. So we have the half that's there. We bring down the power times minus a half. And we have 1 plus x to the power of minus a half times minus 1. And this can be tidied up. 1, so we can multiply the fraction 1 by 1 is 1, but it's a plus by a minus, so we get minus 1 on the top and underneath 2 by 2 is 4, minus a quarter on 1 plus x. Now you can do this in the calculator, do it as fractions or decimals, whatever you want, but I'll just do it as, that's going to be minus 1.5, so I'm going to write it as minus 3 over 2. You can write it as minus 1.5 if you want, right? It's the same thing, or minus 1.5. So we have done 2 differentiations, right? Now if you look at the question, this is the 4th term here. We have, that's the 1st term, the 2nd term, the 3rd term, and the 4th term contains x cubed. So this from the formula is the x cubed, and it's the 3rd derivative. So we just have to differentiate this function one more time, and that's as far as we need to go for this question. So I'll do f3x for the 3rd derivative. And that means we're going to have to bring this power down. So we have the minus a quarter. It's now going to be multiplied by minus 3 over 2 on 1 plus x to the minus 3 over 2 minus 1. And that works out as the fractions and minus by minus will give us plus. That's grand. 3 times 1 on the top is 3. 4 times 2 underneath is 8. And then we have 1 plus x. Whoops, 1 plus x. I'll just make that a 1. I'm so lazy. But anyway, 1 plus x to the power of minus 5 over 2. Or, if you want, minus 2.5, right? So we have done the 3 differentiations that we need. But according to the formula, it's f of 0 and f dash 0. So the next stage is to put in 0 instead of x, right? So we're going to use the x equals 0 next. So that becomes, instead of f of x, we now have f of 0. So all we do is when we have f of x here and we have 1 plus x to the power of a half, we now write 1 plus nothing to the power of a half. 1 plus 0 to the power of a half, which is 1 to the power of a half, or the square root of 1, and it's the answer is 1. Okay, you could say, well, square root of 1 could be minus 1, but if you look at this here, it's 1. We're going with a plus. So the square root of 1 is 1. In fact, 1 to any power will be 1. Then the next one, f dashed 0. So here, we're using this one here, f dash 0, and again, we're putting in 0 for x, so it's going to be a half on 1 plus 0 to the power of minus a half. Okay, that's minus means you put it underneath the line. It would be 1 over the square root of what's in the brackets. In this case, we're going to have a half on 1 to the power of minus a half. 1 to the power of minus a half is just 1. It's 1 over the square root of 1, which is 1. So that's all equal to 1, so we're left with a half times 1, which is a half. If you're in doubt about this, you could plug that into the calculator and you'll get a half. Then we do the second derivative, putting in 0 again instead of x. So we have minus a quarter on 1 plus 0 to the power of minus 3 over 2, which will be minus a quarter on 1 to the minus 3 over 2, which is just 1 again, so the answer is minus a quarter. Right? And if you look, this is f dash dash, that would be this one here, and it is a minus here, so we're sort of on the right track, and we have the half there with the 1 there. Grand. So now, whoops, sorry about that. The next thing is we do f3, the third derivative of x when x is equal to 0 will give us 3 over 8 on 1 plus nothing to the power of minus 5 over 3, or sorry, minus 5 over 2, which will give us 3 over 8 on 1 plus 1 to the minus 5 over 3, which is just 3 over 8. Now, if you go back to the formula and you look at the formula, here, it's f of 0. That's the 1. Then x times f dash 0. So it's going to be x multiplied by a half, and so on. So I'll just scroll down the page a bit. and we'll fill this in. And as you do it, you compare it with the answer that Patty gave at the beginning of the question. So f of x is equal to f of x, which is the square root of 1 plus x, is equal to f of 0, which is 1, plus x, according to the formula, you leave it as x, times f dash 0, which is a half, plus x squared over 2 factorial, times f double dash, the second derivative of x, which is minus a quarter, or sorry, the second derivative of x when x equals 0, which is minus a quarter, plus x to the 3 over 3 factorial, whoops, x to the 3 over 3 factorial times this, which is f3, the third derivative, 3 over 8, plus dot, dot, dot. We're only going that far. If we tidy this up, that will be 1 plus x over 2 plus, well, no, it's a minus now because this minus, okay, x squared on the top, and 2 factorial is 2 by 1, which is just 2, times 4, which is 8, and then the last bit plus 3 over 8 times x cubed over 3 factorial, which is 3 by 2 by 1, and we have the x cubed here, plus dot, dot, dot. Now we can cancel the 3 with the 3 here, and 2 times 1 is 2, and 2 eighths are 16. So we will finally get our final answer, 1 plus x over 2 minus x squared over 8 plus x cubed over 16 plus dot, dot, dot. So that is the that's that part done, part 1, where we've now proved that the Maclaurin series is this. Now the second part of the question was that we had to find the square root of 1.4, part 2. So we use what we've got to find the square root of 1.4. So if f of x equals the square root of 1.4, we have to use the Maclaurin series to solve it, right? So I'll just insert the formula. Well, we have the formula here for Maclaurin series. We're going to use this, right? Now, how does the square root of 1.4 relate to 1 plus x to the power of a half? Well, 1 plus x to the power of a half is the square root of 1 plus x. So we have the 1 for this one here, and x must be 0.4. And we just put it into our function for f of x. So that means we're now looking at f of 0.4. Anywhere there is an x in the series, we put in 0.4. So we have 1 plus 0.4 over 2, 0.4 over 2, minus 0.4 squared over 8, plus 0.4 cubed over 16, plus dot, dot, dot. But that's as far as we're going. And when you put that in the calculator, you get 1.184. So that is our approximate value. So the square root of 1.4 is approximately equal to 1.184. If we were to use more than 4 terms, we would get it more accurate. In your calculator, it's 1.18322. Okay, that's the end of the question. Thanks.